Now let's begin week 6 of Modeling and Statistics class. Today's topic and today's goal is how to make your conclusion with some data. In order to achieve this goal, we will learn about data comparison and evaluation. Let me highlight today's goals. We have mainly 3 goals. I want you to understand at the end of today's class how to make a conclusion based on data. So I want you to make very objective conclusion. Second, I want you to understand the difference between result and conclusion. Lastly, I want you to understand how to evaluate data. We will focus on those 3 points today. Before talking about the details, I want you to think about total number of students at the Yokohama National University as of May 2019, which is 7,416 students. Okay, this is a fact and this is a result. Then the question is, how can you evaluate the number 7416? Please think about it. What does it mean by evaluate? For example, is this too high or bit high, or is it low or somewhere in between? How can you say this number is high or low or too much or too small? That's evaluation. But as you can see, if you focus on this one single number, 7416, even if you understand the fact or reality, still you cannot make any evaluation of the number. But from practical viewpoint, you need to evaluate the number or situation. Then you can make your conclusion and or proposal. That is the goal of today. First of all, let's think about the difference between result and conclusion. In general, when you say result or results, that could be just a calculation result or calculation output. If you calculate the average of the whatever you have, that is a number or numbers or some index. But it's just a calculation. Or you can draw a graph, bar chart or line charts, pie chart, whatever, a graph with a single parameter. Yes, the graph may show the result or fact, but still it shows only a result. You cannot evaluate the output from the number or from a graph. On the other hand, if you say conclusion, that could be an answer to the original question or objective. You may have some objective to use the data, or you may have a question you want to address with number or data. You have to answer, you have to make an answer to the original question or goal. And your conclusion cannot be subjective. The goal is to have an objective conclusion. In order to make a conclusion, you have to have objective evaluation. And from my viewpoint, good conclusion does not have any number. That is a back data. Conclusion itself should not have any number because the number shows only the result. Or conclusion does not have statistic index. So if I address some conclusion, I will not use any numbers in it, or I will not use any statistic index. For example, standard deviation or average or something like that. That shows only results. My conclusion is not like that. Conclusion is some sentences to address the goal or a solution or actions to meet your original objective. Okay, now I want you to understand the difference. Result is a calculation result, and conclusion comes from that result. But conclusion is not the same as a result. And what is our goal? The goal is to make a conclusion based on your result. So from next time, if you share your output or if you have to make a presentation, I want you to have your conclusion based on your results. Okay? So without any conclusion, you should not just show, hey, this is a graph, this is the average number. You haven't reached the goal yet. Okay? I want you to review your assignments this week. Is it results or evaluation? Evaluation means you objectively evaluate the result. Again, we talked about the number of the students at YNU. Okay, this is a result. I give you an example. If you look at product A, sales result, that's a result. If you look at monthly result, you can draw a line like this, and you can say, hey, these sales went up. Yes, that's true if you look at the graph. But again, that is results. I will ask you, so what? What does it mean by going up against your original objective? So in order to answer this question or in order to propose something from data, the first step is evaluation. How can you do that? Evaluation is not just simple result. Evaluation is you compare a data set with another. If you compare the two, you can do some relative comparison. So you can get some relative, you can do some relative evaluation if you compare the two data sets. That is the first step. Okay, if you have only one single data set or one single index, you cannot compare with anything. So you should have several sets of data and then compare these two and then say, hey, you can evaluate like this, like this, like this. So, and finally, your conclusion in general should be based on your evaluation. Once you can make objective evaluation, that will directly support your conclusion. For example, this is a worst case. Yes, I've got the data. That shows the total number of sales, 7,400. That is the YNU's students. Hey, my conclusion is YNU has a large number of students. No, that's not the case. That's your subjective observation, not conclusion, not objective at all. So if you compare 7,400 with other university students number, for example, then you can make some relative comparison. And you can evaluate the YNU student number is higher or lower or something like that. So again, result, this is the first step, and comparison and evaluation, that goes to your final conclusion. Okay, how can you do the evaluation? Technically, comparison. You compare several data sets. That is how you evaluate. Result, evaluation, conclusion. So how to do the evaluation? That's comparison. Again, let's take some time to think about this question. This is a result. If you present about the YNU's number of students to somebody else, how would you evaluate this number? The key word is comparison. how are you going to compare this number with what? That would be your evaluation result. Are you going to compare the last year's student number, or are you going to compare it with the number of students of other similar universities? You have a bunch of ways to do that, and there is no right single right answer. You have to make your own story, and you have to convince your audience with your reasonable conclusion, objective conclusion. That is the final goal of this class. Okay? Now let's review your output of the assignment. This was an assignment. Okay, let me rephrase the goal again. How are you going to propose your strategy plan for the next year based on your evaluation result? That's totally fine. If you haven't evaluated your result, that's okay. But please think about this goal. You have to propose your strategy to your boss for the next year based on these numbers. First, how are you going to evaluate this result? Second question, in order to evaluate this data, how are you going to compare those data with what? And last question is, based on your evaluation result, what is your final conclusion? That can be your strategy proposal for the next year. 3 steps. First, compare the number and make an evaluation. Based on the evaluation, what is your conclusion? Your conclusion should not include any result number or index. Again, practically, these are the questions you have to answer when you make a comparison, when you compare the data sets. First, what data to compare with? As we addressed before, if you compare the total number of students at YNU, are you going to compare with what? With other universities' number, or the same number in the previous year or 10 years ago? That's some options you can have. The second question is how to compare the data set. That's more technical stuff. We've learned 4 approaches to see the data. Total, average, standard deviation, trend or ratio, whatever. You have to smartly and wisely choose what is the right approach to see the data or to compare the data. The approach should fit your goal, fit your conclusion. Sometimes you can combine some approaches. Yes, I will use average plus trend, or I will use average plus standard deviation plus ratio. So more approaches you can have, the more deeply you can address your conclusion. But it depends on your goal. Sometimes the simple is best. So please think about your conclusion and then think about what is the best approach to use based on your goal. These are some examples. For example, if you compare the byproduct, look at the chart A. That is just sales trends. So I applied trend and total. So this is a combination of the total number plus trend. And I compared across the products. As you can see, what can you see from there? You can see the sales trend. So for example, product D sales trends went up, and product B, it went down. That's a simple result. And then what about B? I applied the monthly trend. No, this is a yearly trend, but this is a monthly variance. I applied the standard deviation of each year, monthly deviation of each year. So as you can see, product D has been keeping lower distribution variance. That means they have been very, the risk has been very low compared with other products. So I compared four products in terms of the variance or distribution. You can say that's a risk. So my conclusion from the chart B can be, yes, its risk has been the lowest. So they might capture the customers constantly. That can be a conclusion. How about C? That's product portfolio. And this is the total of the 4 years. And then this percentage or ratio shows how much percentage each product has. This is a comparison of the four products from percentage viewpoint. And the conclusion might be product B sells the most in terms of the percentage, or you can say the remaining three, in this case product A, C, and D, has very similar product sales portfolio. So whatever conclusion you make, your conclusion has to be based on this chart in this case. And lastly, the chart D, I combine the two axes. One is sales result, that's a total, and monthly variance. So I apply the two index. One is total, one is variance. In this case, that's the distributed standard deviation. So you can show the results from the two different approaches at the same time. This is a result of 2017. As you can see, product D sold the most, the highest. At the same time, the risk or variation, no variance or distribution was the lowest. So if you are asked which product was the best one, I would say product D was the best out of the four products, simply because it sold the most and the risk was the lowest. So that would be my conclusion from chart D. Obviously, you can combine some of the chart to make your conclusion. You can choose A and D or C and B, or you can make another chart if necessary. This is just example. Okay, let's review what we have learned so far. First of all, how to reach your conclusion. Again, before you touch the data, before you touch the keyboard, I want you to determine what is your evaluation criteria or policy. In other words, answer this question: what are important factors for the issue? Issue means your goal, objective, or problem. Total number is the most important, or risk or distribution is the most important, or time series, the trend, is the most important, or comparison with competitors is the most important. You have to define it to meet your goal. This is the first step. Second, and you have to select the right supporting data or graph. What are the right forms of data? What is the right approach of the data? And what is the right graph? And finally, based on this result and comparison, you make your conclusion. Don't just read the graph. Okay? Hey, yes, the product D went down. Here's my conclusion. No, that's not yet the conclusion. That's result. Do not read that graph. I want you to hear your conclusion. Okay? If you make a presentation, the order will change. Okay, once, let's assume you complete your presentation. Number one, step 1 to 3. How you present it. Maybe you take another approach. You start with conclusion. This is not requirement or mandatory, but it is very effective to start with your conclusion. What is your conclusion? Hey, here's my conclusion. Then, next step, you have to address how you reach the conclusion. What evaluation criteria policy you applied. Then, here's my data, here's my graph. So, the worst case is, hey, here's a graph. As you can see from this graph, blah, 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 blah. This is my conclusion. No, it's you just read the graph. Okay, start with conclusion, then address your policy or criteria used for evaluation, then show the back data, something like a graph or chart or table or whatever. So I want you to follow this step in order to make a presentation. Here's assignment for the next week. I want you to make your conclusion and or evaluation on COVID-19 situation. Here's rule and process. I want you to choose one area, either Yokohama, Japan, or your own in the country, wherever, and choose the right data and analysis approach. Okay, what data is the most effective to address your conclusion? And what approach would you use? Ratio or trend, distribution, total, average? And make your own conclusion or evaluation based on the comparison. I want you to compare the data with another data to evaluate. And your conclusion must address objective COVID-19 situation of the area you selected. I want to not to use or copy any existing graph. Yeah, you can find many bunch of graph on the net, but I just don't just download or copy the graph. I want you to make your own graph with an Excel. Okay, and I want you to submit by the due. Good luck and see you next week.